I'm not seeing that share button. I can see Supriya Shekdar is presenting. So, do you need to make me presenter? No. Yeah. Okay. Let me know if my screen is visible.
Visible, sir. Your screen is visible.
Okay, great.
Some
Hello,
sound
everyone.
is coming, sir. Sir, some disturbing sound is coming.
Okay, let me. Is it okay now?
Perfect,
Now
sir.
okay, sir. Now okay.
Okay, great. It was the ceiling fan. Okay. Okay. So yesterday we talked about. So just to recap. So what is DevOps? So in that we talked about DevOps definition, bringing development and operations together, and then we talked why DevOps and what DevOps is and what DevOps not, and how it is based on agile methodology. And then we talked about DevOps framework like planning, continuous integration, continuous deployment, continuous testing, monitoring, and then capabilities under that, around 20, 25 capabilities under that. And also we talked about agile methodology, how agile Scrum framework is, what are the roles in that, and how agile is helpful in today's software development deliveries. So today, out of those six framework capabilities, we'll talk on continuous integration. So continuous integration, continuous deployment, those are like very much talked about. When you talk about like DevOps implementation, first thing comes in your mind is CI/CD implementation. So in that, today we'll see what is continuous integration. Then we'll see like other SCM software configuration repository, then code review, and then unit testing, and then see some demos around that. Okay, this is what is today's agenda. So what is continuous integration? So continuous integration is software development practice where members of team integrate their work frequently. So integrating their work frequently means how frequently it can be on daily basis or once in 2 days at least. Okay, and then usually each person integrates. Means when you check in the code on or push the code, then integration will happen in the form of like code merging, and then also build will happen, and it will check that build is successful, and if it's failing then coming back. So what is that complete process to that we'll see, but integrating on a daily basis, and then verified by an automated build unit testing, and also checking code quality using unit testing. So if there are any defects, quality issues, those will be caught there itself and fixed, so that there will not be any more technical debt going forward. So your testing work will be reduced, and as you move forward, quality product will be delivered. So it's like continuous process of applying QA, small pieces of efforts. So this is important. So you are like, as we have seen, like in Agile, you try to give some workable product in every sprint, and then you try to break the requirements in smaller chunks so that you are able to deliver it continuously. So it's just like small pieces of efforts, then it applied frequently, improve the quality in continuous manner, reduce time taken to deliver, and quality is integral part of development. So in DevOps, its quality is not coming in phases, but it is continuous process. It's integral part. So it's like change in culture. So developer will not do some basic testing, manual unit testing during coding, and then it will hand over to testing team to find out the defects in my code. So he himself will find out the defects while developing itself and then deliver less defect-prone code to the testing team. So what is the importance of CI? So integration is hard effort, increase exponentially with number of components. As you see, number of files, number of components, so it will go on increasing. So number of bugs and time since last integration. So these three things, when there are number of components, many components, there are number of bugs, and last integration, it has taken long back, then integration becomes hard. And then in pre-CI, I mean before continuous integration practice, when there was just build automation or builds were happening in a very much manual way. So how it was that branches, streams, trunks difficult to manage going forward. So I have seen like at that time, so around 2000, 2004, like that. So very popular software configuration management tools were there, like TFS, VSS was there. You must have heard that's Microsoft VSS, and also Rational Clear Case or SVN. So those kind of tools were there, but means focus was more on SCM. So bring that tool, and then rest of the things are manual. So lot of wastages in that. So that was not focus, but bringing some good software management tool, and then focusing on branching, streaming, etc. But not like end-to-end focus in pre-CI. Then features are deployed when completed. It was not like breaking into pieces and then deploying it continuously. Build failures and time-consuming fix of latter. So builds were run like when there is some release happening. So first you integrate the code, so it will take a lot of time because of a lot of merge issues, because code is not merged since many days, and then builds are failing. So integration issues, then whole team is trying to fix that, burning their nights. So all these issues we have seen, and then everything not tested. So when you are doing development itself, so developer will do manual testing again. It was not in very professional manner done, and many things were not tested, and they will go in QA for testing, and then that will increase overhead of testing team. So that's why CI is important here. So what are CI best practices? So we try to bring single source code repository. So nowadays, all these source code repositories, as we'll see, Git is very popular. So it has different variants, like GitHub is there, GitLab is there, so like that. But primarily Git is very popular. Along with that, there are proprietary tools like your Rational Pin Consult is there, then TFS is there, Microsoft. So these are also useful now. Then often code merge is another best practice. So I'll show you one branch structure, how branching should be, and how code should be merged, delivered across, and how it is related to the releases also. Then CI supporting branches, your branching strategy should support CI. If you want to merge code frequently, then you should have minimum branches. There should not be any overhead like merging the code. So few merging, and able to release once build, deploy multiple times. So that is one terminology we always use in DevOps. Build once, deploy multiple times. Once you have good build, which is QA now tested, and it's good, then same build will move forward in staging or UAT and production. So you not go on building multiple times. So it will reduce the time. Then automate the build and test. Automate is the mantra in DevOps. So automate everywhere. Then everyone commits every day. So this practice is really desirable, but in practical, it becomes little difficult to adopt, because team really needs to be very disciplined and very efficient doing this. Otherwise, it is felt like it is a challenge and very expert people are required, and then it becomes bottleneck, and the team will lose the interest. So it needs to be done in proper manner, and uh, team should be highly motivated. Then keep the build fast. So fail fast, fail early means it's like you are building early in the life cycle. So whenever code is getting changed, small changes also you are building. So and if it is failing, it's failing early, so that you are able to fix it early. Okay, so it's not going at later stages. Then 80% code coverage. Try to uh, review the code or have unit testing for about 60%, code coverage of 80%. So this will bring in good quality. And there is dashboard reporting. So tools like Jenkins or any other CI tools, they give quite good reporting and notifications, dashboard, etc. And then automated deployment. So that is it's optional, but because on dev environment only in CI you will do the deployment, but you can make it mostly it's done often. So you do the deployment on in automated way. So these are CI best practices. We'll try to adopt those while implementing CI process. Then this is the CI workflow. If you see here, yeah, so this is a source code repository, and so basically this is developers private workspace like Eclipse or .NET. So ID that is used here, and then you push the code to your source code repository. So these two things are integrated again. So you will whatever changes you do in your Eclipse platform, same changes in same tool basically, you will be able to push that into the source code repository. Then as soon as you are having that change happening, then other things will get created here. So project workspace, then your automated build, and then unit test automation, then creating the package, and source code, basically code review also will happen here, and then deploy and publish. So you also use this deliverable repository, kind of artifact repository. So we have seen, you might have heard names like Nexus or Azure Artifactory. So such tools are used where you are packaging packaged builds. Basically, artifacts are stored in the form of versions, and then those are deployed on deployment targets. Okay, so you don't use like hosted folders, individual machines to store the build packages, but those are stored in cloud or yeah, on the server itself. Okay, and then whatever is success, failure, measurement matrix, all those will be in the form of reports and notifications. Those will be sent. Okay. So, and this is server console, something like Jenkins. So this rectangle which you see is kind of Jenkins platform or RTC platform or your TFS one. So this is, and where you do all this configuring the project, examine, reporting. So all configuration and creating those instances. So that part is created in this platform. So this platform basically integrates with tools like your Git or source code, and your Maven and MS build kind of build tools, Sonar Cube like code review tool, JUnit, NUnit, MS test like unit testing tools. So all that is integrated here. So what is exactly integration? We'll see that. So there are plugins type available which can provide that integration so that you can automate it seamlessly. Okay, so this is a CI workflow. So when you want to implement CI, you should implement source code repository. Then you should have product workspace created, and then automate the build, automate testing, automate code review, automate the packaging, and then publish it in a Artifactory repository, and then automate the deployment. So these 5-6 things you will implement in the form of automation. Okay. So yeah, as I was telling, I'll show you some branching strategy. So this is the one. See this part. So what you see here, integration branch and below. So that is continuous integration implementation. So individual developers in Git, they will create their individual feature branch as they are assigned some tasks in Agile to develop, and then coding will happen on this, and then they will commit the code on this branch and then push it to the integration branch. So here there can be their private builds happening. This is complete their private workspace. So they are modifying the code, checking, doing the builds in their IDs, then doing some unit testing, automated unit testing here also, and then uh, pushing code to the integration branch. So all teams who are all members in the team who are working on different features or different files. So those they will push it the code to the integration branch, and then integration branch your CI build will happen. As soon as any change comes on the integration branch, immediately build happens, automated build happens on that, and then in CI fashion, basically all your unit testing, code review, everything happens. If your build is successful, it will go for deployment on dev. If it is not, then it will come back again for fixing here. So what we say that fail fast, fail early. So that way it will be fixed immediately, and then it will again go for integration builds. And once a dev deployment is successful, then same code will be merged into the release branch. So build once and deploy multiple times. So this release branch is just maintained to deploy it on QA, UAT, and prod kind of environments. So that is again automated. So that deployment automation part here that we are going to see in tomorrow, day after tomorrow's session. And then once deployment is happening, so you push the code to the master branch. So master branch, nothing is going to happen. It's just my good branch. So always good code is maintained here. And anytime you want to pull the code when your new work is starting, you are pulling the code from here to your development workspace. So, but what is important, this is the CI branching that is important, because all your work is happening in this area. And once this is quality build has happened here, then there will be minimum bugs on release, because same code is getting pushed. QA will find some defects. Again, you will fix those in development workspace, and again push it for a UAT. And then from UAT it will go to the prod. If there is any hot fix you want to fix, then code will be pulled from master branch and it will be delivered here itself. And then it will also be it will come to your development workspace via this step 1 in the next development phase. And here this is bug branch. If there are any defects, those will be fixed here itself, and those will be part of your integration builds. Okay. So this is like one typical scenario I have seen, but you can have some or other variation, but not many actually. With current Git kind of tool, you will see this area as very common in every project. Only there could be number of instances of this. So this is one. Then if you are having another project or another application you are developing, so there could be another repository, 3, 4, 5 repositories if it's like a big account. But if it's a small project, then you will have this single kind of instance here there. So how CI is viewed. So PM will see the dashboard and what is the status of the project. So yesterday when we were seeing that end-to-end demo of DevOps, so we saw that there was like a pipeline. It was green. So when it was running, it was showing in yellow color. So like that, if it as it was a small change and demo kind of scenario, so there was no red, and there were like only one application and three stages. But in real time scenario, there are multiple projects created in Jenkins, and you will have multiple pipelines there. So as PM, I will go there, see which is in red, which is in green, yellow, and then if it is red, then I will try to focus on that. So as a PM, I will get what is status of my project, which builds are good, which builds are failing, and then if those are failing, I will question release manager or DevOps engineer or development lead, what are the reasons, and we'll go through the reports in detail, how frequently build is failing and what are the reasons. Is it code review is the challenge, because code is of not good quality, that's why build is getting stopped, or unit testing coverage is not enough, that's why it's failing. So such reasons I will try to drill down as a project manager and then take corrective action. If it's a developer, so he will see that his build is not failing. As soon as code is checked in, then he can immediately go to the Jenkins dashboard and see if build is executed, and if it's triggered, then whether it's getting successful or not. If it's not, then he can immediately fix the code, and so he will take care that his build is not broken. Because of his change, build is not broken, and his change is successful. The tester will see that, okay, what is the latest good build, and he will use that for testing. So such views actually are important from individual roles in the project, and they will try to see the dashboard reports, notifications, and work accordingly. Okay, so we have seen good practices. So what is the workflow that, but what are the barriers of CI? So is it really that easy to implement CI? So it's not that way, because you need a lot of automation. You need to change the culture, particularly unit test automation. That again needs extra efforts. So you need one or two people doing writing the unit test cases. Then again, there can be dispute on how much test coverage should be there, how much possible that way. So all those challenges you will face, and so there can be some assumption getting developed that integration delays delivery functionality. So it's taking extra work for developers to keep the pace, as they have to when they are checking build is happening, then again go back and fix. But I wanted to go back and do some other priority work, but I have to fix the build, and that it took my time, and that's why I was not able to work on other tasks. So such reasons can come up. So for maintaining the pace with the integration stream, and the integration incurs the overhead of dealing with build problems. So as I was saying, so there could be overheads felt as such, and it needs a lot of expertise. So team should be having high skills. So they need to be working in expert mode. Highly motivated team is required, and then communication with each other is also required. So when build is failing or merging is failing, then if that change is made by somebody who is sitting at on-site and time zone is different, so you'll have to wait till that person is available, and that sort of collaboration is taking time. So such challenge can be found there, and that needs to be addressed by making the team having some overlap, which is in good way. Like, but if it's a US time zone and India time zone, then really it's like 12 hours different. But if you are in Europe, then at least 3-4 hours gap will be there, and that can be managed. So, but still you will have to manage that. There is never a good time implement continuous integrations. Yeah, so this is one myth. So people do build automation and create some kind of sort of unit testing automation, use Sonar, but it's not really process handshake. It's not done in continuous management way, and it's not that culture is not there. then but still people say we use Jenkins and we use CI. But when we do DevOps assessment, you'll surely find such cases where people say, yes, we use Jenkins, so we do CI. But that's not the truth. And we another reason is people accept, okay, CI is good, but we are busy writing and debugging the code. So there are a lot of reasons, good reasons told for not implementing that, because experts in the project who have done that sort of practice earlier, they will notice that, okay, it's not easy. If CI is brought in project, then you really need to be efficient, and you will be always focusing on the good work. So that sort of excuses will be told that I'm busy writing and debugging the code, etc. So why continuous integration? So you must have understood in last 4-5 slides. So continuous integration reduces surprises and risks, because you are doing continuous development, and as you are finding the failures early only, and in the form of like on everyday basis, so you will not have major surprises and risks that those are coming up. There are many small integrations throughout the project rather than a big one. So as means when you are doing agile development, obviously, but if it's a waterfall, then you are allowed to break your requirement that way, so that you are having smaller chunks, and you are delivering the work in smaller wafers. So, but that brings in good practice. There is no death march at the end of the project, as I told you. So when some release is there, then whole team is burning their nights, burning their weekends. So that sort of things you will not see, because you are integrating your good code, your quality code, and that's why you are confident that when it goes to the production, there will not be any surprises. And it also promotes collaboration in the form of communication and cooperation among the developers. They are working as a team, and they are resolving their challenges within themselves. And project status is transparent because of this automation, and the tools which you use, they produce good reports and dashboards. You are having specified metrics like build failures, deployment failures, then code defects, code review reports, unit test failures, how many unit tests are done, which functionality is tested, then how many components are tested. So all these reports will be in front of everyone, and that's why there is transparency, and everybody needs to work in a professional way. And it's good moral. Everyone sees the project making steady progress. Okay. Any question till this time? Am I going too fast, or is it okay?
No, sir. It's okay, sir. No problem.
Okay.
Any other question from participant side? Okay, sir. You can.
Okay. Thanks. So here it's shown how CI pipeline looks like and what exactly you need to implement. So which tools? So I have mentioned here all this source open source tools basically. So if you are using Java code development, then use Eclipse along with Git repository. So you integrate Eclipse and Git together, and so that whatever changes you make, code changes you make in Eclipse, so those will be committed, pushed to the Git repository within that platform only. So you start with work item story or task assigned to the developer, and then he will check out the code from the Git repository and modify that code in Eclipse. So I have that traceability while checking out that work item. So you will have traceability with the work item, story, task which you are working upon. And then once your code development is done, you commit the changes to the Git repository, and then automated build will start. So build will use Maven and kind of tool to compile the code. And once code is successfully compiled, if it is not, then again you go back, modify the code, then again commit the, so that development cycle will go on till build is successful. And once build is successful, then next thing is, so you do code review during your development also in individual ID, or when integration has happened on the integration stream, that time also you do Sonar code review using SonarQube. And if all thresholds are acceptable for code review, then JUnit testing is done. And once unit testing is successful, then deployment using Jenkins. Jenkins has a lot of deployment plugins for different technologies, like your AICTE or Tomcat or IBM WebSphere or WebLogic. So for such web development platforms, it has plugins. Or if it's just like a simple pushing files, some script files, Python or your Perl kind of development. So you're pushing that to some folder on the server. So that also can be done using Jenkins plugin. So once deployment is successful, then your QA will take over. That QA pipeline that we'll see during continuous testing. So, yesterday we were talking about those three pipelines in that demo, right? So one development pipeline, then your QA pipeline, and then your UAT pipeline. So this is development pipeline. It will hand over. There will be process handshake with the QA pipeline after that, and then it will take over. So today we are focusing on CI pipeline. So these are the steps in CI pipeline. And this all is using Jenkins platform. So Jenkins has integration with all these tools. So what are different CI tools? So Jenkins, very popular. It's open source and used across many even good clients. So there's big clients also. Then TFS, VSTS, Azure DevOps, these are Microsoft tools, and those are also very popular. And but those are just not free, so you need to buy the licenses. But many these big companies, service companies, as well as the other product companies, they are having partnership with Microsoft. So that's why they have all these tool set available for their developers with less expensive license cost, and also support and then consulting practice, all those that is available. Microsoft or IBM or Atlassian, AWS. So those partnership help companies as well as their clients. But this is also one popular tool. And then AWS CI, so that is Amazon owned. So then Rational Team Consult along with Urban Code Deploy, there is also a good solution from IBM. Then Bamboo from Atlassian, that is one CI tool that is also extensively used. Hudson, it is forked from Jenkins only. So there was only single tool earlier, Jenkins, but later this was branched out and Hudson is taken from HP. But still it's free, I think, or at least community edition is free. And then Team City, it has a free edition, community edition free, it's from JetBrains. This is also being used by some of the clients. CodeShip, completely open source. And then GitLab, it has free community edition. So these are the popular CI tools. There are like around 50 CI tools available. But these are the some which at least I have heard of and seen people using it. So we'll just see now Jenkins. So how is Jenkins architecture? So it has this kind of UI here, you see. So user workspace where you actually do your all code modification and that. And when you log into Jenkins, you'll see something like this user interface. And it has at left side, you'll see that also. Here at left side, you'll see the project. So you create projects in Jenkins, and projects will have different build pipelines. Then you have this triggers, build triggers, and this is, I don't know what is, but build. Then you are having build development builds. So here it will be shown. So when it's build triggered, you'll see there, and once build successful, failed, whatever the build result, number of builds, previous build history, all it will be shown in this area. And then post build actions will be shown in this area. So this will see in actual Jenkins screen. Then these are, see, Jenkins plugins is one important thing in all this. So you do automation using plugins. So what exactly is the plugin? So plugin helps you to automate your, when we talk about CI code review, suppose like you want to do code review with SonarQube. So SonarQube is separate tool, right? So you configure SonarQube, so you create project in that, then you point to the repository where your code is there that needs to be scanned, all these things. But in CI, you want to do it in automated fashion. So in Jenkins, you install Sonar plugin. For install means in Jenkins UI itself, you'll have plugins kind of one link. You go there, search for Sonar, and then deploy it in Jenkins platform. And then you need to give what is Jenkins URL, Jenkins server URL, user ID, password, all those things, project name, and then it's ready to get integrated with your CI build. So that, then if you, this is one example, like SonarQube plugin. Other is you are doing build with suppose Maven. Then you deploy Maven plugin in Jenkins platform, and you provide the details like where are the Maven, what is Maven project, a script, so where is your source code in Git, so that branch name, etc. And then it will do a Maven compilation when build is triggered. Or if you take a deployment example, suppose I want to do deployment on Tomcat. Then I install or deploy Tomcat plugin, and I provide a Tomcat URL, server URL, then again authentication, user ID, password there, and some other details, one or two other details are required. And then once build is successful, code will be deployed on Tomcat server. So this is use of plugins. So plugins is like core of Jenkins automation. Then you can have some local scripts also to do more automation or bring some reports, some local applications. Then SSH plugin to connect with the remote servers, remote applications. And this is team build, workspace, project build history. So all these things are there in Jenkins. Okay. So this RWX means read, write, execute. This is the read, write type. This is the read, write type. And then this is for users. This data share is read only kind of. Okay, so this is somewhat high level architecture of Jenkins. Any question on this? Okay. So Jenkins, as I said, it's open source platform, and it has many features to automate CI/CD. So what are different features trigger a build? So there are different ways of triggering the build. So one is like when code is checked in on the integration branch, then it will get triggered, or you can trigger it manually, or you can have like a dependent trigger. So once this project is built successfully, then only start other project. So that sort of dependency. Or when this build is successful, then start this deployment. So dependent triggers basically. Then gets source code from the repository. So it gets integrated with variety of source code repositories like your Git, then SVN, then ClearCase, and Rational Team Consult. So there are even your GitLab, GitHub compilation. So all those code repositories get integrated with Jenkins platform. Then automatically build and test, obviously that is one feature available. And then generate report and notify. When build is successful, then you can configure the notification to whom it should go. So that way, and also you'll see the report, complete report of build and code review, unit testing, all that reports. And then automated deployment, not just on hosted environment, but on cloud also, in Docker also. So those deployment features available. Distributed build. What is distributed build? So in many cases, we see that there are different types of build. Linux build is done different way. Then your Windows build is done say different way. Or it's not possible that one build server will handle all the load. So you will try to distribute the load across the build servers. So you can have build farm created, and when build is triggered from Jenkins server, it will start on those distributed servers, and it will give the report on a single server itself. Or if its build server is remotely placed somewhere at on-site, then you can trigger the build from offshore also. So those sort of distributed build farms you can create in Jenkins. So these are some plugins at right side. Build triggers, then source code management, and these build triggers, build automation plugins along with build tools. So those are available for all sort of build tools, which I was mentioning, like Maven, Bamboo, TeamCity, RTC, and all those. So it's available for all types of build tools. Then source code management plugin available, code review plugin available. And yeah, so unit testing, build reports, notifiers, artifact uploaders. So you can upload artifact in Nexus or in Artifactory or in Urban Code. So you can upload that, do the deployment automation using those plugins. Authentication and user management, it gets integrated with your LDAP server. So you can have like a standalone user database, or you can integrate it with Active Directory kind of LDAP server. So that single sign-on is possible in organization. So that is also possible. So these are triggers which I was talking, like manually you can trigger the build or build periodically. So scheduling that, then build whenever a snapshot dependency build there, or build after the products are built, and poll SCM. So it will poll your SCM tool periodically, and any change happens on the integration branch, it will trigger the build. So that sort of trigger is also available. Okay, and reports, these are some examples of the reports: static code analysis report using check style, PMD, find bugs. So these are all code review tools. And then compiler warnings, you can see, then test report and code coverage reports for JUnit, test NG, MS test, or Sonar, etc. And then open tasks reports are also available. So this is actual UI. So here, when you go to manage Jenkins, you see this. So you can configure the system, configure systems in the form like setting up authentication or making it more organization specific with some kind of UI changes, and also installing some common plugins basically, which are required across your enterprise. So those sort of configuration, then global security, user authentication with LDAP server, then credentials, and this is manage plugins. So this is one important, as I was explaining. So manage the plugins, install whatever plugins you need. Okay. And once you a new atom when you go in here in Jenkins, you create the project and then you start adding the plugins and accordingly you set up your complete build pipeline. So what steps you need to follow, like first source code integration, then trigger the build once change is happening on the source code, then do the Sonar code review using Sonar Cube. You do the unit testing. So such a build pipeline step by step you can configure here. And once you have that, you trigger. So this build queue will be shown here when there are multiple jobs scheduled. So those will be in queue because it will not run at a time in certain cases if server resources are not available. And here you'll see all the status of the builds. Okay, so this was about Jenkins. Any question on Jenkins? So we'll see demo also, but any question or if somebody has used and any experience on share? Okay. So if you want, you can type the questions in chat window that will address once we have this presentation over. So that is also okay. So next thing we'll see version control using Git. So I have taken this Git as one example tool because it's again very popular and easy to use and available as open, free, and you can easily download and set it up on your server. Okay. So there is remote repository in Git. So which will, first thing is cloning the repository in your local workspace on your local machine. And then once you want to add the file or new file is coming up, so you add that file which will go in staging and you modify that in staging area. And once your code modification is successful, you'll commit the code into the local repository. And once build, etc., is your personal build is successful, you are okay with the code, you will push it to the remote repository. So this is the cycle. There are other commands like git commit --a, basically git reset and git reset commit. So all these, there are different commands that also we'll see what are those commands. But basic cycle to start with is, and overall architecture is, there are like remote repository, local repository, staging, and workspace. So you do changes in the workspace and staging, and then commit the changes in local repository, and it gets pushed to the remote repository. So this is the cycle. Okay, so when you install Git, you download it from Git site and install it. Then first thing you'll need to create is create repository, and then you clone it on your local machine and then start working on that with these commands. So what is the difference between other tools and Git? So CVS, ClearCase, VSS, etc. So they in that tool, basically, file was used to get copied on the local server, and then you modify the changes which are local to your computer. So here, if your machine crashes, if your hard disk is crashed, or you delete the file, then your changes are lost. So when changes are available, when you push the code to the server, check in the code to the server, then only its code is available on the server for others also to see. There is little difference in Git. So in Git, so you clone the repository and it start making versions in the local repository also. And when you commit it, here also, when you commit, then it goes to the server. But only changes, it keeps version history in the local machine also. So repo is cloned on local computer, then it complete copy. So it comes as a complete copy on your local machine. Then you modify the code by check in, check out, committing changes, means modifying the code, and then local repository maintains the version history, and when it's ready, it pushes the changes to the server computer. So that is difference between Git and other tools. What are basic different Git commands? Basically, this is Git clone URL. This is the one first used command. Then add file when new files are getting created. Then commit, so which goes to the staging area. Then Git status will give status of the file, where it is and what is version, etc. And then Git difference shows the difference of the file versions. And help obviously show help and pull and push to pull the code and push it to the remote repository. So this was about Git. So just introduction, but as you do hands-on, so going back to the your build pipeline here, just to recall this. So here, so first thing is here, this one. So we are doing this, and once code is pushed, then your next is build automation getting triggered in Jenkins. Right? So these two parts we have seen Jenkins here. How does the build automation? And we just now saw Git repository. Now, third thing we'll see SonarQube. Okay, so SonarQube is for code review and code quality. So how is the good code? How do you identify a good code? So it's simple and readable, does what it should be. So as we have seen, OOPS kind of the object-oriented programming. So code writing has improved drastically. So it's very much structured way of writing the code, and it's very simple and readable. And why it should be simple and readable when new developers are coming in the team, or you are using code in a repetitive manner for as an asset, then it should be simple, easy to understand, so that it can be adopted quickly, or a new person can learn it quickly and start the working. Otherwise, it will be a mess. Then code should do what it should be. It should fulfill the requirement. Then it should be consistent in style. So writing comments or the way you write it, it should not be like much complex looping. Logic should not be much complex. So it should be written in simple way, easy to understand for others. Should be flexible. So when you want to modify it and for different scenarios, it should be flexible that way, extendable across platform if possible. Like when you are having Windows solution, Linux, Unix solution, that sort of, then or even different Windows variants you want to run the code on, then it should be that sort of extendable, testable and committed with tests. So it should not add testing overhead, because you have to write many test cases to test that. It should not be that way. It should be easy to write the test cases and should be well documented. So these are what some of the good code quality attributes, and it should be reliable, maintainable, testable, portable, and reusable. So same thing what I talk here. So these are good attributes. Okay. So SonarQube is used. So Sonar has again two versions. One is Sonar, which is commercial, and SonarQube is free edition. And it's a central place to manage the code quality. So once you install it, then you point it to the code repository, and you configure. It has web UI interface, and it will scan your code and publish the reports with some predefined rules. Predefined rules, thresholds on the web UI. in the form of your dashboard reports. And you can then use that as standalone tool also, or you can integrate with your CI build using Jenkins, so that you are having that CI pipeline, seamless CI pipeline. So it does automatic code scanning, define the rule set. As I said, there are predefined rule set available, but you can modify those. You can add your own rules also. Set the thresholds, create the metrics, and then visual reporting available, dashboard available. So these are some of the capabilities of SonarQube. It supports a good bunch of languages. So common one, what we see is C, C++, C Sharp, your Java, JavaScript. So those are supported. Even ABAP is also supported. Android development is also supported. Okay. So it supports wide variety of languages. So what is this star mentioned? That is, those are commercials. That is commercial support. So if you want to use SonarQube will not support ABAP, but you need to go for then Sonar as commercial version. Do that's code scanning, ABAP's code scanning. Right. So this is some dashboard shown example. This is the way Sonar looks like. Sonar web interface looks like. So how many? This is like a project size kind of view. So how many lines of code it has scanned? So how many files are scanned? Directories are scanned. Functions, classes. So this is shown here. Then how many issues and what is technical debt? Any blocker, critical blocker. So that and any major, minor. So those are shown here. Many duplications, complexity, package, tangle index, so unit test coverage. So this is 95% unit test successful, but unit test coverage is just 20%. So this is what overall my project health is shown here. Okay, then next view is on rules results. So here you will just see this complexity or duplications. How many functions, how many classes, files per file, basically how many. And then issues, yeah. So unit test coverage. So this you will try to focus on quality related issues. And then quality improvement here. So it is again showing. You can see this one here. Issues, blocker complexity in the form of table, quality improvement area. Okay, this is what is Sonar, and here there are different links available which you can use to view or configure your Sonar cubes. Okay, any question on Sonar Cube? You can go for your testing.
So lots of heterogeneity is there regarding the tools as far as testing scenario is considered, maybe in case of automation testing. How that integration can be done?
So integration in CI pipeline or overall DevOps pipeline here?
So the simplest part is what before start of the work we have to do this, or in between changes, means it is a dynamic, or we should once it is planned accordingly only we have to go.
You need to plan it early. So your test automation, surely you need to plan. So what you will identify during planning phase. So when your product backlog is being defined, so you will see how much test automation is possible, then what tools you need to use, whether we can go with open source, or are there any like specific functionalities or way of technology related dependencies that you need to go for some commercial tool itself. So if you are doing some kind of system development, suppose, and Selenium is not supporting your system testing, or if it's IoT kind of development, so then your normal open source tool is not supporting that, then obviously you need to go with some IoT platform kind of Azure or IBM. So such things you will plan early, and you start when you start writing test cases during the requirement finalization. There itself you will identify how complex is the solution and what exactly test cases, test scenarios will be, and accordingly then you can plan your test automation. So how unit testing automation can be done, how much it is possible, how much code can be covered for unit testing. So such questions will be answered there, and you can then do that. Then for performance testing is another criteria. Performance testing, apart from tool, what exactly you want to test as performance. So whether you want to test, means if it is a web application, then and if you are using Tomcat, then what is your load on that? So you need to see your architecture, and according to that performance testing factors, you need to decide. Or another thing is your when you do the testing, so your data management. So if it's a database application, then porting the data for testing during staging. And DevOps says that okay, you should have real-time scenario as your production server is there. You should have your QA servers also. But when it comes from data point of view, are you able to really do that? Bring that much data for testing in your staging. So you need to again have some good data management tool in testing. So such things are there. You can plan it early, but it's done, configuration and implementation is done in continuous fashion.
Can I ask, sir, similar
Sure.
complementary question to what Dr. Saab has asked? Looks like the integration tool that we plan has to be done very carefully. Otherwise, even the system response, if it is a web-based solution, the system response will also change, as you have indirectly indicated. Am I right?
Yeah. So you have to choose tool carefully, but system response will not dependent on the tool. But, but yes, if you are using some testing tool which is not capable of testing that sort of scenario, then yes, what you are saying is right. I agree.
So, sir, apart from the develop process that you're saying, you should take about an hour summary of what tool we should use for which application. If there is some directive on that, that will be of great help to all of us, sir.
Okay. So
Thank you.
there are like overall this development in industry is divided into 3 or 4 types of application. One we call it as custom development. So which is covering your Java and .NET kind of application. And then other is your mainframe development. Okay, so that is altogether different than this. Then third is your enterprise development kind of your SAP and Salesforce kind of tools coming there. And then fourth one, it's IoT, system development, IoT development. So yeah, I'll tell you what tools can be used for each one. There are some tools common which run across, and particularly Microsoft and IBM. So being like large players in the industry, they support all sort of platforms. But when it comes for open source, then yes, there can be some tools not having all the capabilities.
Basic understanding of open source is a tool that can be used for learning, cannot be used for actual implementation on the projects for customer. Is that so?
There are 2 types of open source tools again. See, if you use community edition, then that is completely free, and that's not advisable to use in the setup where high criticality is there. So if it's just for learning or less importance, so to give one example, if you are using community edition and suppose you use it as a mail server, Linux mail server in your college campus, and it goes down. And issue is with your mail software only, and you need support from open source community. So that you will not get because they don't support that one. And then you are completely stuck. And mail server is important for college, right? So though
Yeah.
you are educational institute, but mail server is important. So in such scenarios, you should go for open source edition, which is licensed one, where you get the support.
That
So
is very well
there
said, sir. Very
is
good.
cost is less being open source, but you are getting support also there. Don't go for community edition. But yes, if students are doing some project and you want to set up a lab, suppose, and where student will learn, they will do some college projects, academic projects. So if it goes down and you again set it up, that's fine. So it just time will be like 2 3 days you will need to set it up, but there you don't need to pay and you can use community edition there.
The ideal will be, sir, open source licensed version, which is cheaper and affordable for colleges, academic
Correct.
institutes. I see. Because
Correct.
many
But
people have been saying they are canvassing. One second, sir.
hmm,
Many
sure.
people are canvassing for open source as if it is free. But I firmly believe that if it is free, then it may not serve the real purpose for which it is being used. That's what my feeling
Correct.
was. But you have really
Correct. Correct.
said that in so many words. Thank you, sir.
Yeah. Means I just give one example. So in my previous organization, so it means that time all these companies were small and open source was very popular that time. I mean, today it's also popular, but that time like open source was free to use. And once client visited, he saw that okay, there are some servers running open source software. He said everything is fine, but it's your luck and you are running the setup by God's grace, because he knew that open source is not supported, and if anything goes down, then you are nowhere. So he commented that you are lucky to run that setup. So such things are there. Yeah.
So, Dr. Thigre, sir, please take a note of this. Very important.
Yes, sir. I noted, sir. I
Thank
noted,
you.
sir.
Thank you, sir.
Okay. Any other question or discussion? Okay. Let's go to unit testing. So unit testing, what exactly it is? So you do it to check the functional correctness and completeness, but you do it in small blocks in small chunk. So checking the input values or error handling or correctness of output data. So these are some of the examples, or optimizing the algorithm and performance. And so individual units of source code are tested. So you write unit test code for such units. Then concerned with functional correctness, as I said, typically written and run by software developers. So unit tests are run. So that's why it's again thought of as an overhead. So because there will be extra developer required. So there will be cost. And also if you ask existing developer to do that, then obviously they will need extra effort to do that, and you need to manage your project that way. And goal is to isolate each part of the program and show that the individual parts are running correct. So purpose is to test and validate individual units. So this is what unit testing and why we do it. So faster debugging, faster development, as like fail fast. So that's again means some of the DevOps keywords are coming again and again, and those will come. So shift left, fail fast, fail first, continuous, 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 automate, automate, automate. So such words are there which will come everywhere. So faster debugging, faster development, better design, then excellent regression tool, and reduce future cost. So when if you are catching your defects early, you are improving your quality early, obviously your quality cost will be reduced in later phases. And some of the guidelines of unit testing: keep unit tests fast and small. Then you should not try to test logic or some workflow which is lengthy. So keep it small, fully automated, and non-interactive, simple to run. Measure the test. So how many tests are done? How much is the test coverage? And fail fast, fail early, and fix early also. It's about testing units classes. Uh, as I said, like testing small chunks. Start off simple. So how to start again? I mean, you start with like simple thing, and then you start on building on all that. So it's again a TDD approach also. So in Agile, yesterday I was talking about different tools and techniques. So one of them is test-driven development. So TDD says our start with simple, uh, and then start building upon that. So unit testing is one sort of agile methodology where agile technique do the uh, TDD and BDD kind of testing. Then use proper naming conventions for writing the test. Then test independent, try to avoid dependencies of other blocks, and test the trivial cases also. So you don't know what is trivial and what is important at this point of time. Try to test everything, though it's trivial you feel at this point of time. Then test the boundary cases. Uh, February 29, one example, or month 31st date of every month. So such boundary cases which are coming up. So try to test those also. Then test each feature once, at least once. And yeah, it's more like a TDD, test-driven development. These are some of the guidelines which you can try to use. So what are the major structural testing techniques? So statement testing, you do branch testing, path testing, condition testing, and expression testing. So in statement testing, each statement of program is executed at least once. Okay. So when you are doing testing, you are focusing on small code chunk part, and there you will see each line is tested because each line is important. It is doing something during your algorithm. Then branch testing in which all branches in the program source code are tested at least once. So it means it's going like step by step ahead. So starting simple, then going to branch level, going to at path level, and then doing conditional testings also, and then regular expression testing also. Then functional testing techniques, input domain testing, so which are specific to domains when it comes to like automotive domain or your financial domain. So try to do functional testing related to that. Then boundary values, as I mentioned, like 29 February kind of boundary conditions, and syntax checking. Obviously, you will do that, and then equivalence partitioning. Okay. And then error based. So you will fault seeding. So you will intentionally involve any fault, basically, and then you will try how system behaves because of that fault. If it's like performance related, or if it's related to some data point, which is maybe imaginary, but that can happen. So such fault seeding you will do and do the testing. Then mutation testing, mutating certain testament in our source code. Okay. And historical test data. So if any historical data is there, that you will try to use it and do the unit testing using that. One more thing is also virtualization. So you may have to do that, but that we'll see in later stage because some of the components or dependencies will be there, but you are not able to test that and how you can do the virtualization. So this is example of unit testing code. So here this counter class will be tested, and so here okay, so this is again means basically syntax how you can write the test case, but when you go to this slide, you'll see this. So counter test, and you are calling that counter class here, and you are giving. So you mentioned this as a test increment, basically counter test as a constructor. So this is Java code, counter test as a default constructor, and then you give the input values as counter. So incrementing each time, and then uh, how it behaves. So this is unit test. This is written for this counter as constructor, which is written here in the development form. Okay. And then you run it. You can run this in your Eclipse environment, and also you can run it in JUnit framework also. So how you create JUnit in Eclipse? So you create a file new, means in your Eclipse ID, you go in this path and you create a new test case as a token test. This is basically JUnit test case you are creating. And then when you fill this two parameters, test case and test class, and here, so you modify the code here in this test class, and second, use this pull down menu where you can run the JUnit test. Okay, and where is the JUnit test result shown? Here it is shown. Test result. Okay, it will show. So this is actually manual unit testing, which you are doing in your ID. So every integrated development environment will have such kind of unit testing creation, product creation, and then you can execute unit test cases manually. So as a developer, you will do this, and then in your continuous integration cycle build, it will happen in automated way using JUnit or MS test kind of tool, not automation. Okay, so this is what unit testing. So I covered all these parts. So let me go back and recap what we saw in this. And then we'll go for demos. Yeah, so we covered Git repository, and then build automation in Jenkins using plugins, etc. Then Sonar code review, JUnit, and then Jenkins again using plugins for deployment. So this is build pipeline. So we'll see demos for code review and unit testing. So these are two things. We'll see the demo, and also we'll see CI building, pipeline building. And if time permits, we'll see yesterday's demo again. So you'll understand many things now as basically for CI thing. Okay, are you able to see on my screen? Hello, sir. Can you see my screen?
Yeah, able to see, sir.
Yes.
Okay. I play this video and let me know if you can hear the sound also.
Hi. So I'll be explaining to you how this tool SonarQube is helpful
Clear sound.
in analyzing your code
Okay, great.
and in resolving the code issues and also the coding standard issues that are not being followed. So here in the left panel, if you can see, it shows me how many bugs are not resolved, how many are critical, how many are major, etc., etc. let us come down to this tab, rule. Expand this tab and you can see all the rules that have been applied and all the rules which are having issues with. So let us go to this rule. For example, functions should not be complex. Now as you can see, it shows me for the first file the cyclomatic complexity of this function is 22, which is greater than 20 authorized. If you click on this, it will show you the detailed description of the issue that is coming. So in this case, it just shows that the cyclomatic complexity needs to be reduced. Now what I will do is I will go to this file and as it was given over there, line number 209, expanding this, it shows me the error description over here in this function. So if you can see here, there are a lot of nested ifs inside while and a lot of conditions inside this function, which is making it very complex. So we can go and fix in the code if you feel that this is applicable for our project. Similarly, there are lots of other issues, like for example, the to-do tags need to be handled. The local variable should not be declared immediately and returned or thrown. Instead, we can just write return statement directly. Here there's another one that you can see. If you have chunks of commented code in your project, then it detects this one also. So as we can see here, remove this commented out code, expand it. What does it mean? And we can check here. So line number 258, I go to this file and line number 258. So we can see here we have a lot of commented out lines. It could be commented out code also. We can remove this. Now there's another tab which is rules. This lists all the rules that are there, that are being followed. And here we have something also called as quality profile. So in this particular example, if you have PHP plugin installed, then the PSR2 quality profile can be loaded, and we can actually check the code with the PSR2 standards whether it is met or not, and it will tell us whether the code is not formatted or we are having not proper syntax for the class names, for the variable names. It will point out everything. So you can click on this. It will list you all the rules. Like the file should contain an empty new line at the end. Function should comply with the naming function. So like that, it will list you all the rules and it will match your code to the rule also. I can make another video to describe how we can actually load the quality profiles in our Sonar, because by default this PSR2 will not be present in the Sonar Cube setup that you might have. So that is it. I hope this is helpful. Thank you.
Okay, I'll share the next. So this was about Sonar Cube. I hope it was just 5 minutes video, but it helped to know this UI, and where are rules, what kind of rules are there, and how dashboard reports are seen. So that is explained briefly. So let's share. So next video I'm sharing on unit testing. So how unit test is created using MS test. So that is the Microsoft example that we showed. Visible?
Yes, sir.
Yes,
Frameworks
sir.
Okay.
available for .NET. I've listed a few here. We have MS Test from Microsoft, which is integrated with Visual Studio. We also have NUnit, MBUnit, XUnit.NET. Each of these frameworks have their own pros and cons. In most of the organizations I've been working with, I've used MS Test. MS Test is integrated with Visual Studio. This means we don't have to install any third-party tools. I must also tell you, once you've learned how to use one of these unit testing frameworks, it's not too hard to learn the others. The concepts are still the same. The way we implement them may be slightly different depending on the framework that we choose. Now let's focus on how to create our first unit test using MS Test unit testing framework that comes with Visual Studio. There are three simple steps. The first step is to add a unit test project to your solution. The second step is to decorate the class that contains test methods with test class attribute. And the final step is to decorate the test method with test method attribute. So let's look at all these three steps in action. Let's flip to Visual Studio. So we have a solution here. The name of the solution is Calculator, and the solution at the moment contains two projects. So this project right here, calculator.web, this is an ASP.NET Web application project, and calculator.library, this is our class library project. And if you look at this calculator.web, we have a single ASPX page here, calculator page.aspx. If we view this page in the browser, this is how it looks like. So it provides us the option to enter a value for numerator and denominator. When we click the divide button, we get the result, that is the quotient, displayed in a variable. Now the way we have implemented this is like this. So when we click the divide button on this page, we are calling the divide method that is present within the calculator class. And if you look at this calculator class, this is present in calculator.library namespace. So if you look at the references right here, notice within the web project, we have added a reference to calculator.library project, which is our class library project that has the logic to divide two numbers. There's the same function that we looked at in our previous video session. What we want to do is unit test this divide method. So the first step to do that is to add a unit test project to our solution. So I'm going to right click on our solution, add a new project, and I have selected test under Visual Studio, under Visual C Sharp, and I selected unit test project, and I'm going to call this calculator.test. Click OK. So this should add a unit test project to our solution. And look at what it has done. It has created a class file, unittest1.cs, and that's the name of our class right here. Now I am going to change this name to calculator test. So this is going to contain all calculator tests. So I'm going to change that to that name. And when I do that, it's asking me if I want to change the name of the class as well. So I'm going to click S. So it changes the name of the class as well. Now look at this. The calculator test class is decorated with test class, which is going to contain all our test methods. And the test method itself is decorated with test method attribute. Now look at this, by default it has called it test method 1, which is not a meaningful name. Now we are going to use this method to test the divide method, right? So for now, I'm going to call this test underscore divide. There are naming conventions that people follow to name their unit tests when developing real-world applications. We'll discuss those naming conventions in a later video. For now, to keep things simple, I'm going to name it test underscore divide. Now, to create the unit test itself, we follow this 3 A's pattern: arrange, act, and assert. Within the arrange section, we initialize objects and set the values of data that we want to pass to the method being tested. And during the act section, we invoke the method being tested, and the assert section verifies that the method being tested behaves as expected. So let's look at these 3 sections in detail. Let's flip to Visual Studio. So first, arrange section. So this section initializes the variables and objects that we want to pass to the method that is being tested. So I'm going to create a variable here. I'm going to call it expected, and I'm going to expect a value of 5. So I'm going to store that in this variable. And I'm going to create 2 more variables of type integer. So the first one is going to be numerator. I'm going to initialize that to 20, and the second one is going to be denominator. And I'm going to initialize this to a value of 4. So that's our arrange section. And within our act section, we're going to invoke the method that we want to test. So the method that we want to test is actually present in this project, calculator.library, and our unit test is present in calculator.test project. So within this unit test, at the moment we haven't added a reference to calculator.library project. That means the divide method is not available. So let's go ahead and add a reference to calculator.library project. So I'm going to right click on references, add reference, and then I'm going to select this project section, and from there select calculator.library. So that's going to add a reference to our calculator.library project. Now within the act section, I'm going to use calculator.library. That's the namespace. Within that namespace, we have our calculator class, and within that class, we have our static method divide. I'm going to call that, and it expects values for 2 parameters, numerator and denominator, which we have in these 2 variables. So I'm going to pass those 2 variables, numerator and denominator. So this method is going to return an integer value, and I'm going to store that return value in another variable, and I'm going to call it actual. So we get the actual value when those 2 numbers are divided in this variable, and we have the value that we are expecting in this variable. Okay, so finally, within our assert section, we're going to verify if the method behaves as expected. And to do that, I'm going to use the assert class. This class has got several static methods. For now, I'm going to use r=equal method and check if the expected value, which is 5, is actually equal to the actual value, whatever we get when that method completes execution.
Yeah, so that was it. So it was not executed run in that test here, but it was clearly shown how you write the unit test. So you are using the actual code or development code, and then passing on some parameters and writing the test case to show the expected value, which will compare with the actual value. Okay, so this was one about unit testing using MS test. The next one is building pipeline, CI/CD pipeline. As we talked today about CI, so let's see how CI pipeline can be built.
Hi everyone, my name is Bryant. I'm a community manager and writer for opensource.com.
Is it visible?
Yes, sir.
Okay.
Yes, sir.
I'm also a consultant at Red Hat. Today, I'm going to show you how you can build a simple DevOps pipeline using Jenkins, which is very famous tool for building CI/CD pipeline. That stands for continuous integration and continuous deployment. And so, in this tutorial, I'm going to show you how you can write a simple Jenkins file, and then directly inside the Jenkins. That's going to be first part, and then create a DevOps pipeline, and you can see the result in Jenkins. But on the second part, you're going to pull a Jenkins file from a GitHub, and then Jenkins will pull the information and then create the same result by executing the Jenkins file. So you're going to learn by doing this, you're going to learn how you can write a file, a pipeline file, and then learn the fundamental concept behind it. So without further ado, let's get started. So first thing I want to talk about is that how the Jenkins pipeline or pipeline in general works for DevOps pipeline. So the concept is quite simple. I mean, you have the sequence of stages, and then you call stages, and then stage block. And inside the stage, you have a number of different steps. So inside the step, you can execute anything you want, as long as it is available from the Jenkins. So you can, simple thing is you can print out the message. If you have a Java, you can compile Java and run the Java command, or you can use a Maven, Apache Maven command, Maven clean install or deploy your package. So number of things you can do with depending on how the Jenkins can run. But the idea behind it is very simple. You have a number of things that they can be learned sequentially, and you can pretty much that is all the things you need to know about the pipeline. And then so I mean you can kind of do the same thing with the Jenkins job, but then to make it execute and to follow the sequence, it's not quite simple to point one job to another. So pipeline really helps to make things easier by actually introducing the concept of a sequence, and so it can be more organized, and the jobs can be more and then you can have create a multi-pipeline. So meaning that you can execute in something simultaneously, and then so they can be very, very complicated, but at the same time that's very fun and useful. So that's concept of pipeline. So I guess first thing you want to do is you want to visit Jenkins website. There's a jenkins.io. And then when you visit the landing page, first thing you want to do is look at the top right corner, and there's download the button there. So I'm here at the download the page. You can kind of find all kind of different distributions. There's Microsoft Windows, Mac OS, and then but what we are really looking for is generic Java package, that Word file. So I'm going to click that, and I downloaded the previous Jenkins file before, so I'm going to wait for it, but it's going to be my own download folder. So I create a directory called tools/Jenkins under my username, but you can pretty much put it anywhere you want. So inside the folder, I put the Jenkins.word file. I just downloaded it. So make sure that you have Java installed and JDK, and then make sure that when you execute Java version, you can see that what kind of Java you have installed, and it has better JDK, because we are going to execute the Word file as executable binary Java file. So Word file. So I'm going to say Java hyphen and the current directory and Jenkins Word. What this is going to do is that it's going to start the Jenkins it's just a one time and the temporary. So you don't have to install anything. And once everything is good, you're going to see the message that says that it's going to be up and running. So yeah, as you can see the message, Jenkins is running now. So here's a Jenkins page. You visit http and then slash column slash localhost column 8080, and you should be able to visit URL right there. And you shouldn't ask any password or username unless you create a Jenkins job before or run Jenkins before. So first thing we're gonna do is we're gonna create a pipeline. So you can either click create new jobs here, or you can click new item. They're going to be doing the same thing. And it asks for give some name for your item or the job. So I'm going to say just test pipeline. This doesn't really matter what name you give, but then it's going to just represent what the project is about. So I'm going to select, there's different options. I'm going to select the pipeline because we want to create a pipeline, and I'm going to click OK. So there are different options if you want to play with it a little bit, but what we want to is we want to go to options, say pipeline. And here, what I want to do is that there are two options. There's a pipeline script and pipeline script from SCM that can be GitHub or any source control like Subversion or whatever. We're going to show you both how to do both of them, but I'm going to just show for the first part, I'm going to select a pipeline script. And I have another tab open, another open tab. I have my GitHub page with the CI/CD pipeline, and it's CI/CD practice. So in both of the exercise, part 1 and part 2, I'm going to leverage this GitHub page. But right now, I have just a simple one Jenkins file. I'm going to copy the file, Jenkins file, as a low format, so that it doesn't have any kind of format added there. I copied it, I pasted it. That's all we need. And I'm going to save it. And then once you've done that, you can either click build now here, or you can go back there and there's build the option. I'm going to just click build now. So you're going to execute it. We can see the result, and then by clicking the job, and then you'll see the console output success. So let's go back by clicking the breadcrumb link here. And so you can see that you have built the first pipeline. Awesome, good job. So now you can click each one of them and see, it was able to execute successfully. But let's kind of figure out what exactly we did. So you can kind of see the message, and you can pretty much expect it can be anything. So when you go back to our pipeline, you can kind of see it's pretty simple, straightforward. Actually, let's go to configure and see actually what we put there. And so you see that there is a pipeline. Start with the pipeline, and then it's starting brace, curly brace, and ending curly brace. But between that, there's the stages, and then inside the stages, there's stage defined. And then the name can be anything. I call it a build, but it can be like stage 1 or just play or anything you want. So the name of the stage can be anything. And then under the stage, we have step. Inside the steps, you can kind of put the comment you want to put there. So I'm just giving out the message, and then this is just the default environment variable on values that's available in Jenkins. But simply, if you want to do, let's say Java or Maven, you can say Java, I don't know, some file, or it can be like a Maven, and then just build the package. Assume you have this thing installed, this library and tools installed. So imagine what you can do with this pipeline file. It's in very organized way. So I'm going to, doesn't save it, or just exit out of it. So then the second part we want to do is that, okay, so we are going to do the same thing, except we are going to use the pull from the SCM, which is source control. So I'm going to use a
Something went wrong, sir? No video.
Hello.
Somnathji, there is no video. Something went wrong.
Yes, yes. No video, sir, to me. Prakash, sir? Just second, na, sir. I'll just check.
Hello, can you hear me now? There was some network issue.
Yes, sir. Yes, sir.
Okay.
Video is paused in between or it's same, sir?
Oh yeah, I have paused it. So replaying it again from there. Yeah, so that was it. So how are we doing on time basis? Otherwise, we can go through that yesterday's video again. So can we use 10-15 minutes to see CI part only in yesterday's video?
Yes, sir.
Yeah, okay. Okay, this video we have seen, so I'll just go to it get refreshed.
Have three build pipelines as you can see here: dev pipeline, QA, and automatically. And well, that is so. I have already created an running. I will then initiate the functional test as instance where the dev pipeline resides. So let me just quickly brief you on the web application, the Java based web application that I was talking about. Um, so this is the um, application. It's basically a servlet. It has a home page with a welcome message on it. Also, it has a servlet link which takes you to another page which shows you the number of counts, and it also has a link to the external page, which is the Polaris page. So this application is hosted on this local machine on a Tomcat application server. And the same application, you can see that it is hosted on another machine as well. So this is the QA pipeline, QA environment that I was talking about. Uh, so this machine is an Ubuntu machine, wherein the same application is also hosted on it. And post all these three pipeline completion, we will see another machine as well, which does not exist at this point in time, which will be created as part of the Jenkins pipeline. And you can see the same application getting deployed in that instance as well. So for the purpose of this demo, let me make a change to this um welcome, title, which probably will append it with hyphen intra demo, probably for this uh, demo purpose. And let's see how the change goes through different functional areas in the build pipeline and how it gets deployed into each environment as part of the build pipeline. Before I make changes into the application, let me just give you a quick view of the build pipeline that I have on my Jenkins pipeline view. So this is my build pipeline view. As you can see, three pipeline here. One is the dev pipeline, this one is the QA pipeline, and another one is the UAT pipeline. So dev pipeline is the one, as I told you, where all our quality checks are done, which has unit test in place, which has static code analysis in place, which has uh, performance testing as well in this pipeline. So once that is all completed, the build gets deployed into the local server, and we'll be able to see the change on our local application here. So once that is done, it gets passed on to the next pipeline, which is the QA pipeline, where our Docker image is created, put it into the Docker hub, and then deployed into the Ubuntu server. And you can see the change once it is deployed. You can see the change in just a minute. I'm sorry. Okay, so this page where you can see that change getting reflected. And the third pipeline, as I told you, is the infrastructure pipeline, wherein a new Ubuntu server is created as part of this pipeline, and a new server gets created, and we'll be able to see that server and the application once it gets deployed into that newly created server. So that's all about this pipeline view. Probably once the build gets triggered, I'll show you all the build logs and different metrics collected as part of this pipeline. So let's go ahead and make the changes to the application and see how these changes get deployed into different environments, and see how this new infrastructure gets created on the fly. Before I start making the changes, as I told you, let's create the Jira request and assign it to the user. So I'll just make use of this one, and I'll assign it to a user. So you can see here this Jira request is created for this particular change, and before I start making the changes, I'll say in progress, as I'm going to work on this change. I'll go into IDE. So now we are in the Eclipse IDE. As I told you, I'll just make the changes to this welcome title. As I told you, I'll give it as hyphen infra demo, and save these changes. So I'll now commit it into my Git repository. Before committing it, I'll give the Jira ID that I have created, -15, which is so this is the Jira request that we have created for this change, which is -15. So I'll pass it on to the commit message. I'll commit it to the Git repository. So I've now gone into the pipeline view. Let's see how the changes kicks off here. So the build has started now. You can see the dev pipeline has begun.
Hello.
हा ठीक आहे सर. गुड इव्हनिंग.
Good evening, sir.
प्रकाश ड्रॉप
Bye.
ऑफ झालेत वाटतं. त्यांचं कनेक्शनचे प्रॉब्लेम दिसतात.
Okay, okay. No problem. They have one more session, na? Sir is having. So that time we will cover the remaining part.
हा सरांचं उद्या नाही आहे, मग परवा असेल.
Tomorrow, day after tomorrow, we will cover. No problem. If there is
Yes.
issue because continuously connection going in, going out. So we
Right.
will take a pause here. Day after tomorrow, we will start.
Yes, for the block, for the DevOps, yes, we can start day after tomorrow. Tomorrow, the Canada team is taking a session, right?
Yes. Morning session will be from?
No, no, not morning session. It is 7:30 a.m. their time. So our time is 5 to 7
Yes, 5 to 7. No,
p.m.
first session. First session.
No, no, our regular session will be 2 to 4 p.m. and 5 to 7 p.m. tomorrow also.
Correct, sir. Correct.
So every day our sessions are on same time. Don't go by Canada time sometime when they say 7:30 morning or something. That is their Canada time.
No. As per our time only we will go. 2 to 4. Tomorrow first session will be with.
I will be taking it.
Yes. And 5 to 7 will be by Canada team. Okay,
Yes,
sir. No
for
problem.
tomorrow.
Yeah.
Yeah, Prakash has joined back.
Yeah, I joined back. Sorry, it got disconnected. I didn't notice that. So, shall I play it again or?
Yeah, Tigray sir, you decide what is to be done with this session right now.
So just I think it will need 5 minutes more. Those.
Sir, Prakash sir, we will. Hello, am I audible?
Yeah, you are. Yeah.
We will take a pause here, and you have one more session day after tomorrow. So remaining part we can start over there.
Sure. Okay.
Because continuously connection going on. We will take a pause. Thank you, sir, for your interactive sessions. Thank you all the participants. Tomorrow again morning session we will starting with Atul sir, and second session will be there from Canada team. Attendance for all the session is compulsory to eligible for certificate of AICTE. So kindly follow all the rules, regulations, and instructions given on group. Thank you, one and all. We will take a pause here. Thank you.
Thank you very much. Yeah.
Okay, thank you very much. So tomorrow we'll start at 2 p.m.
Thank you, Atul. Thank you, Ashok Marathe. Ashok
Thank
Marathe.
you, everyone.
Thank you, Hirve sir.
Thank you, everybody.
Bye-bye.
Thanks. Bye.
Swaji, bye.
We'll see you tomorrow. Bye-bye. See you.